What comes to mind when you ponder the future of computing? It's a question that sparks our curiosity and fuels our imagination. In the grand tapestry of human advancement, computing stands as an emblem of our innovative spirit. It all started with the creation of the first computers, colossal machines that filled entire rooms, yet had less power than your everyday calculator. These early computers were a marvel for their time, a testament to our ability to harness the power of technology. As time marched on, so did the evolution of computing. The giant room-filling machines gave way to personal computers, devices that were not only smaller but also exponentially more powerful. Today we live in a world where the computer in your pocket is more powerful than the supercomputers of yesteryears. Our current state of technology is breathtaking, but it's only the tip of the iceberg. As we look towards the horizon, we see the dawn of a new era in computing, an era shaped by the principles of quantum mechanics. This is the realm of quantum computing. Quantum computing is a fascinating concept that promises to revolutionize our world. It's a technology that leverages the peculiar characteristics of quantum physics to process information in ways that classical computers simply cannot. Where classical computers process data in binary bits, quantum computers use quantum bits or qubits, which can exist in multiple states at once. This capability opens the door to an array of possibilities. Imagine solving complex mathematical problems in a fraction of the time it takes today, or simulating the behavior of atoms and molecules with unparalleled precision. These are just a few examples of what quantum computing could make possible. Yet, as with any frontier, the journey towards quantum computing is fraught with challenges. There are technical hurdles to overcome, theoretical concepts to refine, and ethical considerations to ponder. But these challenges only serve to ignite our curiosity and spur us on. The future of computing may lie in the realm of quantum computers. It's a future full of potential, a future that we're only just beginning to explore. So let's delve deeper and discover together what this future holds. So, what exactly are quantum computers? Now that's a question that's been on a lot of minds lately. To put it simply, quantum computers are a new kind of technological marvel that operate on the principles of quantum physics. Unlike the traditional computers we're used to, which work with binary digits or bits, quantum computers use quantum bits or qubits. Now these aren't your run-of-the-mill bits. They're a bit like Schrödinger's cat, existing in multiple states at once thanks to a quantum quirk called superposition. Imagine a coin being spun. While it's in the air, you can't tell if it's heads or tails. It exists in both states at once. That's a bit like how a qubit works. It's not just a 1 or a 0 like a traditional bit. It can be both or anywhere in between until it's measured. But the magic of quantum computing doesn't stop at superposition. There's another trick up its sleeve: entanglement. This is a phenomenon where two or more qubits become linked, such that the state of one directly influences the state of the others, no matter how far apart they are. This allows quantum computers to process vast amounts of data simultaneously. So why does all this quantum hocus pocus matter? Well, it's all about speed and efficiency. Because qubits can represent multiple states at once, quantum computers can process information exponentially faster than traditional computers. Think of it like this. If you were trying to find your way out of a labyrinth, a traditional computer would try every path one by one until it finds the exit. But a quantum computer? It would explore all paths at once. This remarkable ability opens up whole new realms of possibilities, from simulating complex molecules for drug discovery to cracking encryption codes or even modeling climate change. The applications are virtually limitless. In essence, quantum computers have the capacity to process information in ways that are currently unimaginable with traditional computers. And that, my friends, is the basics of quantum computing. But what makes quantum computers so powerful? Well, the answer lies in their ability to process vast amounts of information simultaneously. You see, unlike traditional computers that use bits, quantum computers use quantum bits, or qubits. Where a bit can be a 0 or a 1, a qubit can be both at the same time, thanks to a principle known as superposition. This means a quantum computer can process all possible outcomes of a calculation at once, rather than one by one like a traditional computer. This capability to process multiple outcomes simultaneously makes quantum computers incredibly fast. They can solve complex problems that would take conventional computers thousands of years to crack. in a matter of seconds. But the power of quantum computers extends beyond speed. They also offer a level of precision that's unmatched by traditional computers. This is because of another quantum principle called entanglement, where the state of one qubit can instantaneously affect the state of another, no matter how far apart they are. This interconnectedness allows quantum computers to process information in a way that's not just faster, but more nuanced and detailed. Now let's talk about the potential applications of this power. In cryptography, quantum computers could crack codes and ciphers that are currently considered unbreakable. They could help us discover new drugs by simulating the behavior of molecules at a level of detail that's beyond the reach of today's computers. In climate modeling, they could process the enormous amounts of data required to predict weather patterns and climate change with greater accuracy. The list goes on. In a nutshell, quantum computers are not just faster and more powerful, they're fundamentally different. They have the potential to solve problems we currently consider unsolvable and to explore questions we haven't even thought to ask yet. Quantum computers hold the potential to revolutionize numerous fields with their immense processing power. However, quantum computing isn't without its challenges. Even as we marvel at the immense potential of quantum computers, we must also acknowledge the substantial obstacles that stand in the way of their widespread adoption. The first of these hurdles is maintaining qubit stability. Unlike classical bits, which can exist in a state of either 0 or 1, quantum bits or qubits can exist in a superposition of states. This superposition state is incredibly delicate, vulnerable to the slightest environmental disturbance. Even a single stray photon or a slight change in temperature can cause a qubit to lose its superposition state, a phenomenon known as decoherence. Maintaining qubit stability requires incredibly precise conditions. Quantum computers need to be kept at temperatures close to absolute zero and shielded from all external interference. This makes them not only difficult to build and maintain, but also extremely expensive. The second major challenge is managing errors. In classical computing, error correction protocols are well established, but in quantum computing, these protocols are much more complex. Due to the fundamental principles of quantum mechanics, a qubit cannot be copied without altering its state, a principle known as the no-cloning theorem. This makes error correction in quantum computers a significant challenge. Moreover, quantum computers operate on the principles of quantum mechanics, which is inherently probabilistic. This means that the results of quantum computations are not always certain and can vary from run to run. This inherent uncertainty adds another layer of complexity to the already challenging task of managing errors in quantum computing. Despite these substantial challenges, the field of quantum computing is making remarkable strides. Researchers and scientists are developing innovative solutions to overcome these hurdles. For example, they are working on new materials and technologies to improve qubit stability and devising ingenious algorithms to manage errors. Despite the challenges, the promise of quantum computing continues to push the boundaries of technology. The road to quantum supremacy may be fraught with challenges, but the potential rewards are too great to ignore. So, where are we heading with quantum computing? As we peer into the crystal ball of technology, we can see quantum computing taking shape in ways we can only begin to appreciate. This rapidly advancing field is brimming with potential, and the ongoing research and development efforts are nothing short of fascinating. Just imagine we're in a time when technology is poised to leapfrog over the boundaries of classical computing. Quantum computers, with their ability to perform complex calculations at unimaginable speeds, are at the forefront of this technological revolution. The possibilities are as numerous as they are exciting. Presently, researchers are pushing the limits of quantum computing, exploring new algorithms and working tirelessly to enhance the power of quantum bits or qubits. These efforts are steadily chipping away at the challenges that stand in the way of fully operational quantum computers. The future of quantum computing is not just about faster computations or solving complex problems. It's about a paradigm shift in how we approach computing altogether. It's about the potential to revolutionize fields like cryptography, where quantum computers could create uncrackable codes or break existing ones with ease. It's about transforming the pharmaceutical industry, where quantum simulations could lead to the discovery of new drugs. It's also about the challenges that lie ahead. Quantum computing is still in its infancy, and there are numerous hurdles to overcome. Issues such as error correction, Stability of qubits and the need for extremely low temperatures are just a few of the obstacles that researchers are grappling with. Yet, the promise of quantum computing is undeniable. We're standing at the cusp of a new era, where the rules of computing as we know them are being rewritten. Every breakthrough brings us closer to a future where quantum computers are a part of our everyday lives. The future of quantum computing holds great promise, and the journey there is sure to be a fascinating one.